So if that's the case, then you can be reasonably certain that when you solve a linear equation, the usual techniques that we talked about will get you to that unique solution, right? And the techniques were move all the variables to one side of the equation. In other words, get all the variables so that they're by themselves so that we can unwrap them using reverse order of operations. And then use a reverse order of operations to get that variable by itself. But what happens if we can't even get to a linear equation in order to do that in the first place? What happens if we start with a story problem? And what are some techniques that we can use to approach the solution of a story problem, especially if that story problem involves some kind of challenging arithmetic objects, for example, fractions. So I want to look at an example from Unit 1 that sets up a story problem in such a way as to, they think that they're going to require you to put together an algebraic equation, a linear equation that involves fractions in order to solve this story problem. But I'm going to actually show you kind of two ways of approaching this. One way that actually has you translate the problem into algebra per se, and then solve an equation using algebra. But we're not going to do it that way in the beginning. For the first approach to it, we're going to look at a way of just sort of talking our way through it, sketching the right picture, and maybe coming up with a method of solution that doesn't involve us using algebra, but only arithmetic, which would certainly be a benefit if we can get away with it. Oops. So for this example, I want to go to objective 50, which is called solving a fractional word problem using a linear equation. And this is the problem that involves Ruben and his gas tank. His gas tank is 2/5 full in the beginning of the problem. Then he goes and he buys 6 gallons of gas, and afterwards his tank is 7/10 full. And the question wants to know how many gallons in total does Ruben's gas tank hold? So we got a couple things going on, right? We got a story problem, which means that all of the arithmetic operations that are going to help us in this problem are buried inside of the context. So it's going to take a little bit of work to take those arithmetic operations out of the context of the verbally stated problem and into a method where we can understand them mathematically. We also have fractions, which of course is everybody's favorite thing. So let's talk strategy first. And because I'm very visually oriented when it comes to understanding mathematics at all levels, really, I like to start by drawing a picture. That's just how I'm wired. And there are a couple different ways to do this. When I first read this problem, I thought let's think about what his gas gauge looks like. And so I'm going to sketch out his gas gauge over here on the left. He starts out at 2/5 full. Let's suppose that the top of the gauge is both empty and full, which would be maybe a little confusing, but I kind of thinking of the gas gauge like a clock here or something. So 2/5 is a little less than a half, so it's maybe down toward the 5 o'clock position on the clock. So that's where his gas starts. Then he buys 6 gallons, so presumably the needle's going to go up. And when it goes up, it's going to go up to the 7/10 level. So this is kind of a depiction of what's happening in this problem. And the question is, how many gallons in total does his tank hold? So if the needle went all the way to full, how many gallons would be in his tank? And so that's what I tried to do when I first drew a picture for this problem. And I realized it might not be the most useful picture for the sake of figuring out the arithmetic that we need in order to bring this problem home. So then I decided to look at it a different way. Let's think about his gas tank instead of his gas gauge. So I'm going to kind of draw his gas tank as this little cylinder here. And in the beginning, his tank starts out 2/5 full. So the gas level is sort of 2/5 of the way, slightly less than half. It's actually 40% of the way from the bottom to the top. So that's where his gas gauge is going to begin in the problem. At the end of the problem, his gas gauge is going to be 7/10 full. And so the level of gas in the tank is going to be 70% of the way up the tank. And the difference between those two levels is supposed to have been the 6 gallons of gas that he bought in the problem. So this is a new diagram that I think is going to be a little more useful to helping us figure out what's going on in this problem. He starts out 2/5 full, then he throws 6 more gallons on top of it and ends up at 7/10. And the question wants to know, how big is the tank? I want to know how big this total tank is. So let's talk about an approach that doesn't use algebra for a moment. And that approach starts, for me, by asking, well, how much of the tank is made up by this 6 gallons that he put in? And the answer to that question is going to ask us to determine the difference between how full his tank was in the beginning, 2/5, and how full his tank was at the end, 7/10. So what I need to know is, what's 7/10 minus 2/5? How much of the tank is that 6 gallons? And so it looks like we have to subtract a couple of fractions, 7/10 minus 2/5. Because both of those fractions, though, have denominators whose factors are only 2s and 5s, 5 and 10, that means that we can write decimals for these instead of fractions. If that makes you more comfortable, it's something you can do, right? And I'm going to encourage you to use decimals anytime the decimals terminate, right? So fifths, tenths, 20ths, 25ths, 50ths, hundredths, halves, fourths. Anytime your denominators have only factors of 2s and 5s in them, your decimals will terminate. And then using decimals comes with no loss of accuracy and can be very much easier cognitively to figure out. So I'm going to turn 7/10 into 0.7 and 2/5, which is the same as 4/10, into 0.4. Because it really is simpler to subtract two terminating decimals in their decimal representation instead of doing them with fractions. 0.7 minus 0.4, line them up and subtract a decimal point, is going to give me 0.3. So now I'm able to say that the 6 gallons that Ruben just bought makes up 0.3 of his tank. The question then is, if 6 gallons is 0.3 of the tank, then how much is the tank? Well, it's going to be 6 gallons divided by 0.3. How do we do 6 divided by 0.3? Well, let's just move the decimal point in the denominator to the right one to give me a whole number. But if I do that, I have to move the decimal point in the numerator to the right one also and turn 6 into 60. So 6 divided by 0.3 is the same as 60 divided by 3. And that's a pretty friendly whole number division problem whose solution is 20 gallons. So according to this, Ruben's gas tank holds a total of 20 gallons. Let's talk our way through the problem one more time. This would have meant that Ruben started at 2/5 full. At 2/5 full, he would have had 2/5 of 20. That's 8 gallons in his tank in the beginning. So Ruben started with 8 gallons. Then he goes and he buys 6 more gallons. And so we know now in total, Ruben is going to have 8 plus 6, 14 gallons in his tank. Now, what proportion of 20 is 14? Well, it's 14 over 20. And if I reduce that fraction, 14/20 becomes indeed 7/10. So this would appear to be a correct solution to the story problem that we started with here. And we didn't have to use algebra to get there. We just drew kind of a clever diagram. And there was enough suggestion of arithmetic in that diagram to help us figure out how to reason our way into the size of Ruben's gas tank. Of course, it's a little bit not dishonest. This is a really, really good way to solve this problem, if I do say so myself, but it doesn't use algebra, right? It doesn't help you to get practice with solving linear equations that involve fractions using the techniques that we're learning about algebra. So for the sake of completeness, let's take another look at this problem that does involve us using algebra, probably the way that the authors of this problem originally intended us to do. So using algebra, what we need to do first of all is figure out what's our unknown quantity, what's our variable, what's the thing that we want to solve for. And highlighted in orange on this slide, we can see that what we were solving for in the first place was the size of Ruben's gas tank. So let's make that our variable. Let's call it T, T for tank. So if T is my variable, what do I know? I know that Ruben starts in this problem with a tank that's 2/5 of the way full. So how much gas is there in that purple slice? If the tank holds T gallons and it starts at 2/5 full, then that must mean that Ruben is starting with 2/5 times T gallons of gas. But then Ruben goes and he buys 6 more. And so how many gallons in total does Ruben have at the end of the process? On the one hand, just looking at the diagram, Ruben has the purple gas, 2/5 T, added to the green gas, which is 6. And so in total, he has the sum, 2/5 T plus 6 gallons of gas. And that's one way to look at how much gas Ruben has at the end of the problem. But it doesn't help us to solve for T because we need to look at this amount of gas in another way as well. How do we look at it in another way? We have to remember that we know that at the end of the process, his tank is 7/10 full. So on the other hand, we can look at the amount of gas that he has at the end of this process as 7/10 of a tank. So on the one hand, it was 2/5 T plus 6. On the other hand, the amount of gas he has at the end is 7/10 times T. And the claim is that those two amounts of gas are the same. That's what gives us an equation to solve. Without that equal sign, there's nothing we can do. But once that equal sign is put into the problem, now we have an equation. It happens to have t's on both sides. It happens to have fractions. But we know now, based on the techniques that we've seen sort of today during office hours, how to get the t by itself and solve this equation. So what's our strategy? The first part of the strategy, because we have fractions, should be to get rid of those fractions, nuke them, blow them out of the water by clearing denominators. In this example, we have two different denominators to contend with. We have a fifths on the left-hand side. We have a tenths on the right-hand side. So to clear both denominators simultaneously, we can do that by multiplying both sides by any common multiple of 5 and 10. The smallest common multiple we could choose, which happens to be the easiest one to work with, is 10. In other words, if I multiply both left and right-hand sides of this equation by 10, then all of my fractions will be gone. And I'll have only whole numbers to work with, and what a wonderful world that will be. So multiplying by 10 on both sides of this equation, distributing across the addition on the left, will give me 10 times 2/5, that's 20/5. 20/5 is better known as 4, which is a whole number because that's the whole point of this process. And then I'll have 10 times 6, that'll give me plus 60. And on the right-hand side, 7/10 t times 10 is going to cancel the 10s and leave me with just plain 7t. So now my denominators are cleared. There are no more fractions, but we do have a variable on both sides, a t. So let's tackle that by getting all the variables to one side by subtracting. Subtracting all variable terms to one side. And in this example, I'm going to choose to subtract the 4t. We could have done it the other way, but this way is a little nicer because it's going to give me only a single term on both the left and the right once I'm done. So subtracting 4t from the left is going to leave me with just 60. Subtracting 4t and combining like terms on the right will leave me just 3t. So my equation is 60 is equal to 3t, which I can solve using only one step in the reverse order of operations, dividing by 3 to get that 3 off of the t. And the solution that I get is t equals 20. And wouldn't you know, the solution that we got to this problem doing it the algebraic way hits the nail on the head with what we got doing it without algebra. But this way is somehow a little bit more satisfying because we were able to plug in these algebraic techniques that we've been working on building today in other contexts. So the big takeaways from what we looked at in office hours today are, first of all, any equation or inequality that you want to solve that has fractions on both sides, or even on one side, right? Clearing denominators is going to be your friend. In one fell swoop, it eliminates all the fractions that could otherwise screw up your arithmetic along the way and gives you problems that only have whole numbers in them once you're done. Clearing denominators is going to be the best technique that you forget to use all the time, so don't forget to use it. And the second takeaway is what happens when there are variables on both sides. And the answer is always the same, fortunately. It's add or subtract to move the variable terms from one side of the equation to the other. Because once the variable terms are all on one side of the equation,